Hello everyone. Today I'm going to start this new blog post, understanding this new blog post, which was released on March 6th, like 2 days back, and it talks about identifying wildlife with SpeciesNet. Let me clarify this before I start this blog post. The aim of making this video is not to teach, but to learn myself. And if in the process I record this video, if in this process it is useful or helpful for someone, that is good, but I am in no way claiming that I am a machine learning or AI expert, or I'm here to teach you. No, I'm here to do a self-learning process, and in the entire process, just record myself and put it out for anyone else to see or learn along. So let me start my learning process. Where wild things roam, identifying wildlife with SpeciesNet. 1 year ago, SpeciesNet, a tool that uses AI to automatically identify species in camera trap images, went open source. Okay, let me see what is SpeciesNet. Okay, was it in news? Okay. Okay, 3rd March it was on TechCrunch, which says Google releases SpeciesNet, an AI model designed to identify wildlife. Okay, Google has open sourced an AI model, SpeciesNet, designed to identify animal species by analyzing photos from camera trap. Okay, so it can identify animal species from a camera trap. This is the camera trap API GitHub repo. SpeciesNet, an ensemble of AI models for classifying wildlife in camera trap images. Okay. 1 year ago, SpeciesNet, a tool that uses AI to automatically identify species in camera trap images, went open source. Now, more people than ever are using the Google developed tool to further research and conservation efforts. Okay, motion triggered cameras or camera traps are giving everyone from homeowners to park managers an unprecedented view of their social wildlife. While a curious backyard user might be able to identify a critter by eye, let me see what it means. Critter, a living creature by eye, while a curious backyard user might be able to identify a critter by eye, larger projects are now collecting thousands or even millions of wildlife images that could take decades to identify manually. Okay, today more people than ever are using AI to identify animals in their images using SpeciesNet. Okay, this Google developed AI model can classify nearly 2,500 animal categories in camera trap images, thanks to conservation partners who have provided 65 million labeled images to train the model. Originally part of the online platform Wildlife Insights. Okay, Wildlife Insights, what is it? So it seems to be a platform. Okay, bringing cutting edge technology to wildlife conservation. Wildlife Insights streamlines decision making by providing machine learning models and other tools to analyze, manage, and shape. Okay. Okay, so if I search for, say, some African country, okay, what are these images? Total images, and you can download it. Okay, yeah, you can download. Okay, so this is like data set of species images. Okay. Originally part of the online platform Wildlife Insights, a year ago we released SpeciesNet into the wild as an open source tool for others to download and adapt and refine. Okay, over the past 12 months research groups around the world have used the open source SpeciesNet model to spot pumas and ocelots in Colombia, elk and black bears in Idaho, cassowaries and musky rat kangaroos in Australia, and lions and elephants in Tanzania's Serengeti National Park. The AI model is allowing more people to ask broader questions about wildlife patterns and conservations. SpeciesNet is part of Google Earth AI. Okay, a collection of geospatial tools, datasets, and AI models for deep planetary intelligence. Okay, transform planetary information in actionable intelligence. Build on years. So Google Earth has a AI section or a team where they are doing research in like geospatial sections, geospatial areas. Okay, all right. So earlier SpeciesNet is part of Google Earth AI, a collection of geospatial tools, dataset, and AI models for deep planetary intelligence. Earth AI empowers communities and non-profits to address some of the planet's most pressing needs. Okay. A new era for wildlife monitoring. Today, almost all effective wildlife monitoring relies on motion-triggered wildlife camera traps. Okay. Cameras are typically mounted on trees in most cases. Motion by heat radiating bodies triggers a few seconds burst of imagery. Increasingly affordable technology is letting projects deploy dozens or even thousands of cameras, generating vast amount of data. Okay. SpeciesNet leverages deep learning to automatically identify animal species present in camera trap photos. This automation accelerates research, facilitates more efficient data analysis, and ultimately supports more informed management and conservation. Okay, so basically SpeciesNet uses deep learning to identify species present in camera trap photos. Okay, identify animals is important to gauge population health and get early warnings of any changes, to study animal migration, especially in response to a changing climate, and to get evidence-backed measures of population sizes to manage those populations. Okay. Citing of rare or endangered species is also crucial to understand and protect threatened populations. Okay, now coming back to focus on SpeciesNet. SpeciesNet's training and performance. SpeciesNet is a global scale model that classifies 2498 categories, including mammals, birds, reptiles. SpeciesNet work in concert with another open source model called Mega Detector. Okay, let us see what it is. Mega Detector is an AI model that helps conservation folks spend less time doing boring things with camera trap images. Okay, so it's an AI model that identifies animals, people, and vehicles in camera trap images. This model is trained on several million images from a variety of ecosystem. Okay. If you're looking for a species classifier, check out SpeciesNet, a species classifier that plays nicely with Mega Detector. Okay. To determine which images and which pixels within those images contain animals. Okay. So SpeciesNet work in collaboration with another open source model called Mega Detector. Okay, fine. SpeciesNet produces a species name and confidence level for each animal it identifies. It identifies Ocelot 84%, Puma 99.2%, okay, including multiple animals of the same or different species in a single image. SpeciesNet can process about 30,000 images a day on a standard laptop, or 250,000 or more images a day on a low-end gaming GPU. These images are captured in Colombia by Project Lusitania at the one of the participants in this. Okay. SpeciesNet has been operational within Google Cloud based Wildlife Insights platform since 2019. Wildlife Insights is a community platform that hosts approximately 200 million images with human verified labels. SpeciesNet helps Wildlife Insights users label their images. Any of those labeled images that are human verified can in turn provide training data for SpeciesNet. SpeciesNet has been operational in the Google Cloud-based Wildlife Insights platform. So Wildlife Insights platform that we saw earlier, this one, has been using SpeciesNet, and Wildlife Insights is based on Google Cloud and has been using or operational since 2019. Okay, since almost 7 years. SpeciesNet is being used by Wildlife Insights on top of Google Cloud. Wildlife Insights is a community platform that hosts approximately 200 million images with human verified labels. SpeciesNet helps Wildlife Insights users label their images, and any of those labeled images that are human verified can in turn provide training data for SpeciesNet. Okay, so SpeciesNet helps Wildlife Insights users label their images. Any of those labeled images that are human verified can in turn provide training data for SpeciesNet. Okay. SpeciesNet was trained on a set of over 65 million images, including curated images from Wildlife Insights user community, as well as labeled images from publicly available repository. The model uses a convolutional neural network to identify animals down to the species level. Okay, you not just identify an animal, but you also tell like which exact species it is. If possible, in varying conditions of light, angle and distance to the subject. This extensive training dataset has enabled this extensive training dataset has enabled SpeciesNet model to find 99% of images containing animals as measured on a held out test set of camera trap projects 83% of the time. It categorizes animal down to the species level. 94% of those predictions are correct. Oh, nice. Okay, so out of the images, 83% times it is able to tell which species it belongs to, and 94.5% times the prediction is correct. Further details regarding the model's training data, performance and evaluation can be found in our 2024 publication. Okay, so it is able to identify which species it is and to what confidence level. Now, SpeciesNet partner projects around the world. Over the past year, some standout projects include billions of wildlife images from the African savanna captured since 2010 through the Snapshot Serengeti camera trapping program can now be analyzed. Okay, so there was some camera trapping program called Snapshot Serengeti, and high frequency annotated camera trap images of 40 mammalian species in an African savanna. Okay. These are the cameras that trapped it. So there was a program called Snapshot Serengeti, which in 2010, which captured a lot of images, and SpeciesNet partners partnered with this, like, and SpeciesNet was used on top of the data that was collected in this program. While early images were analyzed by citizen scientists, over time the influx of images outpaced the volunteers' capability. With SpeciesNet, Todd Michael Anderson at Wake Forest University is now analyzing this trove of some 11 million images in just days. Okay, so earlier volunteers were hired to manually label those images, and now SpeciesNet model is able to not just identify an animal but also tell the species in that image, and also tell the confidence level of that detection, and also like 99 or 94% time, 94% of those predictions are correct. So this helps like in labeling image data. So this is one of the projects SpeciesNet has partnered. Another one, several groups have adapted SpeciesNet to their local species in Australia. A Wildlife Observatory of Australia has trained a version of SpeciesNet on animals not included in the existing 2498 labels. While OBS trained SpeciesNet on images of species found only in Australia, such as mushy rat kangaroo, government, wildlife and transportation agencies are using SpeciesNet to help process their camera trap data. For example, Idaho Department of Fish and Game. Then millions of new users now have access to SpeciesNet through public-private platforms, web-based resources such as Natural Conservancy, Camera Trap Data Platform. Okay, these are the various programs in which SpeciesNet is being used to label the animals. Looking ahead, in releasing SpeciesNet as an open source resource, we aim to foster collaboration and accelerate advances in wildlife monitoring and conservation worldwide. The GitHub repository provides access to the code, documentation, resources. Let us look at the GitHub repo. It is named as Camera Trap AI, and it can identify animals, species, by looking at the images with 94% prediction as correct. Okay. We encourage the community to continue to contribute to the project, refine the model, and expand its capabilities as early adapters of the open source tool we have done. Research groups and or individuals who prefer a platform that easily and quickly runs SpeciesNet and manage data and collaborate with other groups are encouraged to explore the Wildlife Insights platform, a global resource for biodiversity monitoring and management. SpeciesNet represents a significant step forward in automating and accelerating the analysis of wildlife images from baboon to wallabies. Our goal is to support development of AI models in an ongoing collaborative effort. Okay, so this understanding, reading this blog post was very useful for me, as I got an understanding of SpeciesNet, the open source model by Google, where they are able to identify species from camera trap images with high level of like predictions, like 94.5% of the predictions are correct, and 83% of the time it categorized animal to the species level with the confidence level that it was able to detect them. And this SpeciesNet program is being SpeciesNet model is being used across various projects across the globe, and any wildlife related research work which involves AI might be able to use this in their research. So that is the learning I got from this. If there is anything I can build on top of this model, I will let you know. I will record that as well. I hope this was useful for someone. If not, then it is definitely useful for me, and I'll keep reading more such amazing research blog posts and keep uploading on my channel. Thank you.